Welcome back. So now that we have some more knowledge under our belt, what are some other aspects of sine and cosine that we should be aware of? Well, when we look at the domain and period of sine and cosine, we're going to notice some things, some similarities. So since angles repeat after 360 degrees, or 2 pi, the values of x and y will remain the same for coterminal angles. Sine and cosine values will repeat. So in this sense, sine and cosine are periodic. So whenever they repeat their pattern over and over again, that's a periodic function. So let's define it more specifically. A function f is periodic when there exists a positive real number c such that f of t plus c is equal to f of t for all t in the domain of f. The smallest number c for which f is periodic is the period of f. So again, the period. So we're going to see some of these things pop up later on in this chapter, but for now, just a little bit of an introduction to what this means. So again, if it repeats, then it's periodic. So a lot of trig functions, all trig functions are going to be periodic in some way, shape, or form. So what does this mean? Well, we're going to see some examples in a second, but as far as other aspects that we need to be aware of is the even and odd nature of the trigonometric functions. So sine and cosine and secant functions will both be even functions. So remember, from way back earlier in the course, if we have an even function, we know it has symmetry in the y-axis. Yes, that's correct, the y-axis. So because of that, we have these following equalities. So the cosine of a negative t should be equal to the cosine of positive t. And similar for secant. Secant of negative t equals the secant of t. However, all of the other ones are odd functions. So again, if it's an odd function, that means it's a reflection in the origin, not the x-axis, the origin. So in this case, we have these equalities. So you can see anytime we have these negative angles, then we're going to have, it's going to negate the entire function. Same thing with these ones over here. So let's take a look at a couple examples. So we have evaluate the trigonometric function using its period as an aid. So we have the cosine of 7 pi over 3. Now remember, we have that unit circle. We have all those nice special angles in there. But is 7 pi over 3 on that unit circle? No, it's not on that unit circle because it's way too big. Specifically, it's bigger than 2 pi, right? So what can we do to try to get the cosine of that angle? We could try to put it in the realm of that unit circle. So in other words, let's find the angle that's smaller but coterminal to it. So if we found the coterminal angle to 7 pi over 3, all we'd have to do is subtract 2 pi. So if we subtract 2 pi, which is 6 pi over 3, that'll give us a pi over 3. So we can conclude that the cosine of 7 pi over 3 should be equal to the cosine of pi over 3. So now all we need to do is go back to our unit circle, which was right on the previous page, and let's see, pi over 3. Pi over 3 is 60 degrees, and we want the cosine, so it should be a positive 1/2, that x value. So that should be our answer here. Slide this back down, and we're done. Very similar process over here. So we have an angle that looks way too big to be on the unit circle. So we're going to have to find that coterminal angle again. So 19 pi over 6 minus 2 pi. So again, I'm writing lots of extra steps just to make sure everybody's on the same page. So it looks like we get 7 pi over 6. So that should be the same. So what is that? Well, let's go back to our unit circle. 7 pi over 6. So we can see that that's going to be in the third quadrant, 210 degrees. So the sine. So again, the sine is the y value, so we want that negative 1/2. So that should take care of this problem. Not much to it, but again, that knowing that it's coterminal, knowing that it's repeating is the key to this. So and then we can find those coterminal angles and knock it out. All right, example 4 is going through that other instances of even and odd. So we should be able to use that to our advantage to answer these parts. So if we know that the sine of the angle is 1/2, what should be the sine of negative of that angle? So because it's an odd function, remember this should be equal to negative sine of t. So if the sine of t is 1/2, and we want negative sine of t, we should get negative 1/2. Done. Cosecant of negative t, well, we could tackle this a couple of different ways. We could use the even odd formulas on the previous page, or how are these two angles related? Or these two trig functions related, rather? They're reciprocals, right? So we could easily say that this is negative 2 over 1, which is negative 2. And we're done. All right. Let's try the next one. Cosine of negative t is negative 1/5. Well, cosine is even, right? So if we know it's even, then this should be equal to the cosine of negative t. So this one is pretty cut and dry. That should be negative 1/5. Done. But now the secant of negative t. Well, you can see that these are reciprocals again, and so we should be able to just flip that over. Now, if you didn't remember this part of it, you could go back to use the trig function. So this should be equal to the secant of t because it's even. So you could find the secant of t, but it all kind of overlaps itself. Same idea over here. We could have said this was equal to the negative cosecant of t. Well, if we know the sine of t is that, we can flip it over and negate it. So still get the same answer either way. A lot of overlap in techniques within this section. So one way is not the only way. All right, the very last question is just making sure you know how to use your calculator correctly. So this should be really fast. Use your calculator to evaluate the trigonometric function. Round your answer to 4 decimal places. The only thing to be absolutely careful about is what your calculator is in for units. So if you turn on your calculator, something like this, you can see right off the bat, this is DEG, which stands for degree. So if you want to use radians, you're going to have to change it. So usually you'll have a button like this. If you hit it, you can see it changes to rad, to grad. So grad is something you will never use, more than likely. So rad is what we would want to set this to because there's no degree symbol on this. If there's no degree symbol, then you have to infer that it's radians. So very, very simple with a calculator like this. Put in your decimal, hit sign, and you're done. And because it's in rad, you know you're all set. So, and they wanted it to 4 decimal places, so just make sure you put out enough places. So 0.56, 4642, and so on. So we'd round that to 0.5646. And now, again, we want to keep it in rad because now we can definitely see that we have an angle in radians. But to put it into your calculator, well, you want to make sure you try to be as precise as possible. Now, can you use 3.14 for pi? Possibly, but if you're not sure, read the directions. The directions will say, what to use. Use an approximation or use the button on your calculator if you have a button. If you don't, well, then you're going to have to memorize what pi is equal to a fair number of places. So 3.141592653 should be plenty of places. So if we divide that by 8, that gives us that. So again, remember that's our angle. So we want to take the tangent of that. So there should be our answer. So 0.414213562 and so on. And we'll round that to 4142. All right. So again, just be really careful when you use your calculator. Make sure you're in the right setting. Make sure it's using either degrees when you want degrees or radians when you want radians. So very important. All right, but that wraps up this section. So onward and upward to 4.3 in the next video. See you soon.